Section 11.9 Ripple ciphers. Ripple ciphers, also called wraparound ciphers or end-around ciphers, are block ciphers based on a principle entirely different from the ciphers earlier in this chapter. The basic idea is that each 8-bit character in the block is used as a key to encipher the next character to its right. This, in turn, is used to encipher the next character, and so forth, rippling down the length of the block and wrapping around at the end. That is, the last character in the block is used as a key to encipher the first character. Ripple ciphers are best suited for software implementations, since they offer little opportunity for parallel operation. There are a wide variety of ripple ciphers. They may have any block length from 2 up, and the block lengths may vary periodically or randomly. I suggest a minimum block length of 5 characters, but you might prefer to start at 8. For example, you could use the chained digit generator to choose the block lengths. When the generator produces the digit D, you could make the length of the next block D plus 5, or perhaps D plus 8, or even 20D. Blocks may overlap. For example, you could use a fixed block length of 8, with blocks starting at positions 1, 6, 11, 16, every 5 characters. The last block could wrap around to the start of the message. When the message length is 20, the last block could consist of characters 16, 17, 18, 19, 20, 1, 2, 3. Ripple ciphers are purely substitution ciphers. They involve no transposition at all. The simplest form of a ripple cipher is to exclusive OR each successive character to the next one. So xn gets replaced by xn-1 exclusive OR xn. Then xn plus 1 is replaced by xn exclusive OR xn plus 1, and so forth, rippling through the block. There are many ways to use the preceding character to encipher the next character. A partial list follows. Here, A, B, and C are simple substitution ciphers, and P is a general polyalphabetic cipher. A of X, B of X, and C of X represent the character X enciphered with A, B, and C respectively, and P of KX represents the character X enciphered with P using the key K to select the row in the tableau. Since XOR or SXOR may leak information about its operands, I recommend using XOR S instead, so that the simple substitution is done after the exclusive OR to mask the waveforms, namely A of xn-1 XOR xn. Notice that madd is simply a special case of sadd. That is, pxn-1 is just a particular choice for A of xn-1. The advantage of madd is that it does not require a preliminary setup phase to mix the substitution alphabet. In the same vein, note that this simply permutes the rows and columns of the tableau, so it is equivalent to this, just using a different tableau. The strongest of these ripple methods is poly, where the preceding character xn-1 is used as the key to select the row in the tableau used to encipher xn. I call this method a key ripple. This would require a tableau of 256 by 256 bytes. If this is too large, xn-1 can be reduced to a smaller range by applying a reduction substitution to xn-1 before using it as a key. For example, x could be reduced to x mod 16 or to brackets 13x plus 5 mod 32. Suitable reduced ranges are 0 to 15, 0 to 31, and 0 to 63. If R is the reduction substitution and P is the polyalphabetic substitution, then xn will get replaced by this, where Q is a polyalphabetic cipher with a reduced tableau consisting of the top 16, 32 or 64 rows of P's tableau. If you cannot use a polyalphabetic cipher, perhaps because even the reduced tableau uses too much space, or because the setup time is too long, the next best choice is to use 3 simple substitutions. Replace xn by either of these. This is called a space-time trade-off. The 3 simple substitutions may take a little longer than the single polyalphabetic substitution, but they reduce the space needed from 65,536 bytes to 768 bytes, a 98.8% reduction. Ripple ciphers are not restricted to using only the preceding character to encipher the current character. You can go back several characters if you wish, for example replacing xn by a of xn minus I, XOR xn, where I can be any value less than the block size. It is also possible to use more than one previous character, for example xn-2 plus xn-1 plus xn, or, more generally, xn-j plus xn-k plus xn. Using general polyalphabetic substitutions, xn could be replaced by this, or endless other combinations. As I mentioned, any block size can be used. The substitutions can begin at any character in the block and end at any character in the block, provided that every character gets substituted at least once. You may go several times around the block if you desire, wrapping from the last character to the first where needed. It is even possible to overlap more than 2 blocks, or to have a block lie entirely within another block or set of blocks. The block sizes, the starting positions within the block, the number of characters to be substituted, and the overlap with the preceding and/or following block can be fixed, can be varied periodically, or can be generated randomly. Ripple ciphers can be taken even further. A message could be enciphered using several rounds of a ripple cipher. In each round, the message could be divided into blocks of different sizes, so that the block boundaries line up infrequently or never, and encipherment begins and ends at different points in the blocks. This gives a mosaic or even kaleidoscopic effect. There are too many variations of ripple ciphers to enumerate. The ratings for these ciphers can range from 4 to 10. Here are a few examples. The simple XOR ripple, using fixed-size blocks with 2 rounds of substitution starting at the first byte of the block and ending at the last byte, and using only the preceding byte as substitution key, is rated 4. A SAD ripple cipher using varying-sized blocks starting at a variable position in the block, going for at least 3 rounds of substitutions, ending at a variable position, and using the preceding byte as the substitution key, is rated 7. A polyripple cipher using varying size blocks starting at a variable position in the block, going for at least 3 rounds of substitutions, ending at a variable position, and using the preceding byte plus 1 other byte that varies from block to block as the substitution key, is rated 10. Mosaic methods are stronger than single-layer methods.